All right, so page 4, side angle side proof number 2. We're given that XW is congruent to XY and XZ bisects angle WXY. Using those two bits of information, we need to prove that triangle WXZ is congruent to triangle YXZ. So, first given statement, XW is congruent to XY. That we'll put it here. Our reason is given, and we'll go ahead and mark it on our paper. So, XW and XY. Nothing else I can really pull from that. Just two sides are congruent. Next up, XZ bisects angle WXY. So we'll write that here in our second spot. It's given to us. So now we go on the picture and mark it. XZ bisects angle WXY. So this angle right here is being bisected, which means it's just getting cut in half. That's what it means to bisect something. Is we're just cutting it in half. The midpoint of a segment bisects the segment. So in the same way, this thing right here, XZ, bisects my angle. So I am out of, or excuse me, so knowing that XZ bisects WXYZ, then we know that that creates two smaller angles. And so these two smaller angles will be angles WXZ and angles YXZ, and those two angles will be congruent by the definition of an angle bisector. So now at the moment, I have got a set of congruent sides, a set of congruent angles. Well, I'm out of given statements, so I need to either look for a reflexive side or a pair of vertical angles. So in these two triangles, they both share this side, XZ, meaning that the XZ of this bottom triangle would be congruent to the XZ of this top triangle. They both have an XZ, so I can say that XZ is congruent to XZ by the reflexive property. So now how do we determine which test they're congruent by? Let's cover up one of the triangles, okay, the best that I can. So once you've covered up the triangle, you're going to name it, name the parts you've marked in the order that they're in. Side, angle, side, side, angle, side. Whichever way you look at it, it's side, angle, side. So we can say these two triangles, triangles WX, this should be WXZ, and YXZ are congruent by side, angle, side, triangle congruency. All right, page 5, angle, side, angle, proof number 1. We're just going to keep on going through with each of our congruency tests. So we're given QR bisects angle PQS and angle PRQ is congruent to angle SRQ. So first statement, QR bisects PQS, that is given to us. Okay, so QR is bisecting this angle up here. Now, when a segment bisects an angle, it cuts that angle in half. And these two halves that are created are angles PQR and angles SQR. And these two angles are going to be congruent to each other. So that's why we write here. Angle PQR is congruent to angle SQR. And they're congruent by the definition of an angle bisector. Okay, next up, we're told that angle PRQ is congruent to angle SRQ. So PRQ and SRQ are these two angles down here. So this angle, angle PRQ, and SRQ, they're congruent to each other. That's given to us. So now at this point, I'm stuck. I need to determine how I can figure out which tests I can use to prove these two are congruent. So I need to look for either a reflexive side or a pair of vertical angles. So I do have that reflexive side. It is this side right here, QR. So I can say that the QR for the left triangle is similar to the QR for the right triangle by the reflexive property. And now how to determine which test these two triangles are congruent by. We're going to cover up one triangle and we're going to list the parts that we've labeled in order. Angle, side, angle, angle, side, angle. Either way we go. Angle, side, angle, angle, side, angle. So these two triangles, PQR and SQR, are congruent by angle, side, angle congruency. All right, page 6, angle, side, angle proof number 2. We're told that AC bisects angle BAD and AC bisects angle BCD. Using those two bits of information and this picture, we need to prove that triangles BAC is congruent to triangle DAC. Well, starting off, we're told AC bisects angle BAD. We'll write that down as our first statement, write our first reason it's given, and then we're going to mark it on our paper. So AC, which is this middle line here, bisects angle BAD. Now, when an angle is bisected, when anything is bisected, that means that it is cut in half. So we have two new angles that have been created, angles BAC and angles DAC, and these two angles will be congruent by the definition of an angle bisector. Next up, we're told AC bisects angle BCD. So we'll write that as our third statement and write our third reason it's given. So now we'll mark it on our paper. AC, again, this middle line, bisects angle BCD. So this angle has been bisected now, angle BCD. Well, when angle BCD gets bisected, it again creates two congruent angles, angles BCA and angles DCA. And so these two angles will be congruent to each other by the definition of an angle bisector. So now at this point, I'm out of given statements, so I need to look either for a reflexive side in my two triangles or a pair of vertical angles. So I do have a reflexive side. It's this side right here in the middle, side AC. So my fifth statement, the AC of the top triangle is congruent to the AC of the bottom triangle, okay? Because both of these triangles, the top and the bottom, share this side AC. So these two will be congruent by the reflexive property. So now lastly, how do I determine which test that these two are congruent by? I'm going to cover up one of my triangles. And so if I got my two triangles covered up and I'm just looking at one, I know that I've got angle, side, angle, triangle congruence. Okay, so if you're unsure about which test to call them congruent by, just cover up one and then just name the parts in the order that you've marked. So we can say the triangle BAC is congruent to triangle DAC by angle, side, angle congruence. Next up, page 7, angle, angle, side, proof number 1. So we're told SR bisects angle QST and angle SQR is congruent to angle STR. So let's go through this step at a time. First up, SR bisects angle QST. We'll put that in our first statement. Our first reason will be given. So now let's go on our paper and let's mark that. So SR bisects angle QST. So when we bisect something, we cut it in half. So when we cut angle QST in half, we instinctively create two new congruent angles that are half of the original. And these two new congruent angles are angles QSR and angles TSR. So angle QSR is congruent to angle TSR by the definition of an angle bisector. Okay, next up, we're told as our second given statement, angle SQR is congruent to angle STR. So we'll mark that down here, SQR and STR. We'll write it down as our third statement. Our third reason is that it's given. So now at this point, I have no more given statements. I need to look either for a reflexive side or a pair of vertical angles. So in this image, I do have a reflexive side. It is this side right here, SR. If I was to take these two triangles and split them up, there would be an SR for the left triangle and an SR for the right triangle. So my fourth statement will be that segment SR is congruent to segment SR, and this is by the reflexive property. So now, how do we determine which test that they're congruent by? We'll cover up one triangle, and then we're going to name the sides or the angles in the order that we mark them. So we have angle, angle, side, or even if we go the opposite way, side, angle, angle, which reverses just angle, angle, side. So we know that these two triangles will be congruent by angle, angle, side, triangle congruence. All right, page 8, angle, angle, side, proof number 2. We're given that angle XWZ is congruent to angle XYZ, and segment XZ bisects angle WXY. Using these two given statements and our picture, we need to prove that triangle XWZ is congruent to angle XYZ. So first given statement is XWZ is congruent to XYZ. So we'll label that as our first statement, put given as our reason, and we'll mark it on our picture. So angle XWZ here and XYZ up here. Next up, XZ bisects angle WXY. That'll be our second given statement. So if XZ, this middle line, bisects angle WXY, that means that angle WXY here is getting cut in half. And so if it's getting cut in half, there are two new half angles that get created. Angles WXZ and angle YXZ. And these two angles will be congruent by the definition of an angle bisector. So I'm at a given statement, so I need to look either for a reflexive side or a pair of vertical angles. Well, in this triangle, I do have a reflexive side. It's this side right here, XZ. So I can say that the XZ of the bottom triangle is congruent to the XZ of the top triangle. And that's going to be from the reflexive property. Then lastly, how do I determine which test that these two are congruent by? We're going to cover up one and just name the parts we have in the order that we marked them, just going around the shape. Angle, angle, side, or even if we go the other way, side, angle, angle, it's just backwards for angle, angle, side. So triangle XWZ is congruent to triangle XYZ by angle, angle, side. Okay, so page 9, hypotenuse, leg, proof number 1. We're given that triangle QSR and triangle TSR are right triangles, and we're also given that QS is congruent to TS, and so we need to prove that triangle QSR is congruent to triangle TSR. So my first given statement is a little bit different from the rest of them, but that's because hypotenuse leg is a very unique test. QSR and TSR are right triangles. We'll write it exactly like that. Our reason for this statement is that it's given. So while we never necessarily need to assume that we know what angle measures are if we're not explicitly told, if we're told that these two triangles are right triangles, meaning they have one right angle, I think it's pretty safe to assume that these are going to be the right angles that we can mark. Okay? Next up, QS is congruent to TS, so we'll mark these sides right here. So now we need to look for a reflexive side or a pair of vertical angles for the amount of given statements. We do have a reflexive side here in SR. The SR to the left is congruent to SR for the right. That'll be our third statement, and they're congruent by the reflexive property. So lastly, how do we determine which test of these are congruent by? We'll cover up one. So we've got a right triangle, we've got a pair of legs that are congruent, and we've got the hypotenuses are congruent. So these two triangles will be congruent by hypotenuse leg. Page 10, hypotenuse leg proof number 2. We are given that segment PR is perpendicular to segment SQ. That's a different symbol we haven't seen in a while, but that just means perpendicular. And PQ is congruent to PS. So let's go through and write the proof of this. First up, segment PR is perpendicular to segment SQ. That'll be our first statement. It's given to us. Now, recall from Unit 4 that we talked about perpendicular lines, or two lines that are going to create right angles. So if we have PR is congruent to SQ, then that means that where they intersect, right angles can be constructed. They're created. So then I can then make the assumption then that if these two lines are perpendicular, then that means these two angles, angles PRQ and PRS, are right angles. So that'll be my second statement. Angle PRQ and PRS are right angles by the definition of perpendicular. So if they are both right angles, that means they got to be congruent. So angle PRQ is congruent to angle PRS because right angles are all congruent. Next up, we're told that PQ is congruent to PS. So that's one of our given statements. Now we're looking for a reflexive side or a pair of vertical angles. We do have a reflexive side here, PR. So PR is congruent to PR by the reflexive property. How to determine which test these are congruent by? We'll cover up one, and we see that we've got a right triangle, the hypotenuse, and the leg. So these will be congruent by hypotenuse leg triangle congruency.